Alright, let's quickly solve Advent of Code Day 6 in Crystal. I previewed this last night and it looks pretty straightforward. So I only have like 15 minutes here to give this a shot. Basically, we're given time and distance, and we're holding down a button for a certain amount of time, then letting go, and the amount of time that we hold it down for is the speed at which it travels for the remaining time. So for instance, if we held the button down for 1 millisecond, then we have another 6 milliseconds to travel at 1 millisecond per millisecond, which gives us a total distance of 6. If we hold the button down for 2 milliseconds, we have a remaining 5 milliseconds. Times 2 gives us 10. And so I did a little bit of playing around with the math of this, and you can pretty much generate these numbers given an initial amount of time. And so that's what we're going to do first. Let's actually just parse this input and then solve the exercise here. All right. Let's go back to day 6 and then get the input. Okay. So let's just take a look at what the input looks like. Oh, wow, I was expecting a lot more times and distances than that. It's pretty small. Okay, well, let's grab time and distance as we'll do input dot split on new line, and then take each one and map it over a little function here where we first chop off the we do line.lchop. Oh, okay. Okay, let's first just split it into time and distance there, and then we'll reevaluate what time is. Time is equal to time dot L chop time, and then we're gonna do dot scan of digits, and then we're going to do a map to convert them into, actually, you know what, I don't even need to chop it off, to be honest. Yeah, okay, let's go back in time here. We don't even need to chop it. We just need to scan for the digits, and then we need to just map that into integer. Cool. That'll give us time and distance. And then I think we can put this into a little hash thing. I think there's something called zip in array. If it's not an array, I think it's a hash. Turns an array of tuples populated with the elements of self and others traversed in tandem. Yeah, okay. So let's just say pairs is equal to time.zip distance. Okay. All right, let's solve part 1 now. Pairs dot, what are we looking for? We're looking for the product of all of these numbers. So we could, let's just do a map for now. Each one's going to give us a time and distance. So I don't need to put parentheses around that. Okay. No, I just realized that there's actually this, instead of returning an array, you can just zip. And that'll give us a function with both. Yields elements of self and others in tandem to a given block. Raises an index error if any of the others doesn't have as many elements of self. That's kind of cool. Okay, so we can just do right here time.zip distance and give it the block. That's going to give us x and y, time and distance right there. Okay, so let's calculate first the numbers that we need. So this is what a little math that I did here. Let me pull it up on Slack on my phone and then transfer it over. Okay. So for instance, if time is equal to 1, obviously you can't do anything. If time is equal to 2, you only have 1. If time is equal to 3, you end up with 2 and 2. If it's equal to 4, you end up with 3, 4, 3. It's 5, you end up with 4, 6, 6, 4. 6, you end up with 5, 8, 9, 8, 5. All right. So basically you can see that this first one is always, in the first column we always have n minus 1. And then we can see the next column we have powers of 2. So we have 2 to the power of n minus, well, I guess 2 to the power of 1, so 3 minus n minus 2, I suppose, what it is. Right. And then we have 3 to the power of n minus 3, right? And that just kind of keeps going. Okay, so I think what we need to do is we iterate over from the beginning of, let's see, 1 to time. We start at 1 or we start at 0? I think we start at 1. And then we say dot map. And we say well, we don't want to do a map, do we? What do I want to do here? Okay, so there's always going to be one less. So I suppose we can do 2 time minus 1. Okay. And then we'll say let's map it to um, x. So this is going to be x to the power of x minus nope yeah, x to the power of n, which is time minus x. All right, let's see what that does. Did not mean 2a. Why is 2i not a thing? Oh, okay. I think I need to pull off the first. Wow, it took a while and then did nothing. Okay, what's going on here? Just make sure that we pulled out time correctly. Okay, so we did do that. Now let's make sure that we are iterating it over time correctly. Here we are. So why is this one not working? Maybe it needs to be each. In tandem to a given block. Okay, an example with multiple arguments. Does it not yield anything? If I do puts that, maybe it doesn't return anything. Yeah, there's no return type for zip. That's kind of frustrating. Okay, let's take a look at what it produced here. 42, 40, 42, 44, 34, 32, 34, 44, 42, 40. That does not look like it's correct at all. Okay, so we're going to do pairs is equal to that, and we're going to do pairs.map. So we're going to remove that and then figure out our math here. So this one is equal to 1 to the power of n minus 1. I think that power thing is wrong. I think it might be that instead. Arithmetic overflow. Okay, maybe these need to be I-64s. Let's go divided by 2. Well, that shouldn't change it because we're actually still going to reach the highest number. The highest number is the midway point. So let's just, well, we know that the numbers are like 44, so let's subtract off like 20. I guess that's the twist to this problem, is that these numbers are large. Sure thing. Okay. Okay, let's just go to like 7. Wow, still? What's going on? Okay, well, those are not the right numbers. For 7, we should be expecting 6, 10, 12, 12, 10, 6. Okay. All right, well, unfortunately, I'm out of time, so I will continue solving this